All right, good morning. Well, good weekend.
I had a good weekend. Actually, I don't know. Mine was a mixed bag. I had a whole bunch of sick kids. This is my first day actually getting back today.
All right, what kind of horse does a cowboy ghost ride? A cowboy ghost. A nightmare. What do dancers drink with their lunch? What do dancers drink with their lunch?
Combo,
A what?
combo.
Oh, that's actually pretty good. Milkshake. Tap water. What kind of bird insults people? A mockingbird.
Good job. Getting hot. Been freezing in my office all morning long.
Okay, so today we are going to pick up with access permissions, but before we do that real quick, just a little review. So I've got a directory that I just created called test directory. I put a file in it. I wound up going back up a directory. Then I created this tar. Is this tar command correct?
Is there anything that's wrong with it?
You put like a J argument, so it would encrypt it.
Perfect, perfect. So this would be compression right here, and I did not specify that additional dot. What should it be? What should it end with? I heard somebody say it again.
.bz2.
No, dot Gz. No, I'm wrong. You were right. J is BZ2. I'm sorry about that. If it was a Z, I thought I put a Z up there.
If it was a Z, then it would be the GZ. So sorry about that. All right. Now, what's some things you can point out that
I did correct. What are some of the steps that are needed? Anybody just pick out something? Say that again.
You were outside of following your window.
Perfect, perfect. Yeah, a CD out of the actual file that I was wrapping up with. And again, kind of that strange syntax. Instead of source destination, we have the destination and then the source right here. And again, we have to specify that extension right there. It will not do it
for us versus if we just use like gzip or bzip by itself, it'll automatically add that extension on and we don't have to. It's just one of the quirks right there. All right, good job. Okay, so access permissions here. Today it's kind of a brain overload right here. I will tell you, the lecture doesn't flow well because there's just so many pieces and we kind of just got to get through it. And then at the end, we kind of put it all together, but I try to do it in somewhat of some stages here. So I got my pen. That's right. Perfect. So right here, we have an LSL command. So the ls-l again is that long listing. So we get some of that metadata that we don't get. So if we take a look at, you can kind of see this first placeholder right here, of course, a dash. So a dash just means it's a normal file. There's nothing special. If it was a directory, we would have a D right there. I think we learned if it was a symbolic link, we would have an L right there. There's a few others, but those are the primary ones you're going to see on your system. So that first one is telling you the type of file that we have. Of course, the next set, and we will cover this more in depth on the next slide, is our actual permissions that are being supplied to the file right here. And this one we'll learn at the very end of this lecture. These are called ACL flags. They are outside the scope of this class. They are not on your system by default, but they are commonly used. But there are some advantages and also some major disadvantages when it comes to using those. Now, we talked about soft links and was it soft links? No. Is it soft or symbolic? I can't remember. Symbolic, yes, symbolic. Okay, so we had hard links and then the symbolic links. This is not anything that's really important in our class. So hard links came first, and what they did is they created a little counter right here so you could easily see if you're looking at a file, is it linked anywhere else on the system? Now, why they didn't continue this with a symbolic link, I don't know, but symbolic links won't increment that counter whatsoever. You just don't know. Next, we have the owner right here, also referred to as the user. And that's just whoever created the file, or not necessarily created, because you can change that. It's who has ownership of that file currently. And then we have group. So that is the group that owns that file. Of course, there could be many users applied to that group right there. So many people could have ownership of the file. Then we have the file size. And then note that this is modification time. It's not creation date. So every time you edit this file right here, this timestamp will increment with it. All right, so now those file permissions. So we have 3 types of file permissions. We actually have 3 more we'll discuss at the end of this, but these are kind of the primary ones right here. Read, write, and execute. Pretty simple, but make sure you pay attention to this in the top corner because it will change. So these are file permissions. So read allows you to read the file. Write allows you to edit and make changes to that file. And then we have execute, that is ability to execute that file as an actual program there. And then we apply these 3 permissions to kind of these 3 groups. And I hate to use groups, but that's kind of the best word. So we have user, which again is going to be that owner. Then we have the group. And then we have another one called other, and that's everyone else that is not in those first 2 groups right there. So user and other. So it would just be everybody else but these people right here. So we can kind of separate the permissions out by the user, probably have elevated. You could then lessen some of the permissions with group. And then maybe you could say everybody else, you don't want anybody else that you don't know touching the file. So everybody else has no permissions if we want to set it up. It's kind of up to you. Now, make sure you note the change. We are working with directory here. So with a directory, read is now the ability to actually read the contents of a directory to see how many files are in that directory. Write allows you to add and remove files in the directory. Note that the files in the directory would have their own permissions. So that doesn't mean that you have the ability to edit a file, but you do have permissions to add or remove it from that directory to complete. I don't know what I was saying right there. The ability to add and remove, but not the ability to edit. We'll just go with that. Now, execute, this is kind of the strange one right here. If you have execute permissions on a directory, then you can actually CD into that directory. So without that, so if you had, read, you could even have read and write permissions. And then if you don't have execute, then you wouldn't be able to CD into it, but you'd still be able to list the files if you wanted to. You just couldn't be in the directory. So kind of strange how you could kind of mix and match some of these permissions on your directories there. All right, now that we kind of seen some of the bare bones of this, now here's some commands that we can actually use to manipulate these. So chown for change ownership allows you to change the owner and the actual group on the file. Then we have another one, just chgroup. So notice that it doesn't have the ownership, but it can just change the actual group right here. So it's kind of cool. I tend to like to simplify things. I tend to use ownership because it can do both. Now, we'll see a little bit later that I'll just go ahead and sell it. So like ownership, you could just specify a new user. But if you change the group, it requires you to still specify the current user and then the group. In other words, you can't just change the group information right here without also specifying the owner. So it is a little bit more typing. So if you did have a bunch of groups to change and no owners, then chgroup is probably a little bit quicker for you, what you got.
So in Slide 33, it shows the all the information I'll get on the last second. There's RWX and WX are -X. Are those the read-write permissions in 3 groups?
Yes, we'll see that here in a second, but you called on, yes. The first 3 is user, the next 3 is group, and then the next 3 is other. And now we have change, modify. So chmod is what we tend to call that. And that's how we actually change the file permissions, that read, write, execute that we saw along there. And then note that either only the person that owns it, or if you are root, or if you have some type of sudo. So that's super user covers root and anyone that has sudo privileges. That's the only people that can actually change that value. And then we'll talk about a UMask in a second and how this actually affects the default permissions that are given to files upon creation. So here's some examples right here on this one. This right here, I kind of put a note right here. You could actually use root because you would have your username and you would have root on the system, but it does require that there be a user named Terry. So you obviously don't probably have that on your system, so you can't use this example as it is. But if we do chown and specify Terry and then specify our file that we're going to apply that to, then that would change that file's ownership. So now Terry would actually own that. And of course, if we want to change the group, we could change it that way. Now, if you chown to do both, note that you must specify Terry, even if Terry is the current owner of that file. You always have to specify that username when you use chown to do both. And then you can separate it with a period, or you could separate it with a colon. You'll see both of those. I meant to add that in the second one, but I forgot right there. So we'll just pretend in the second one that's a colon. So now that would change the owner and the group. And then, like I told you, we'll come to this. We got recursive. So if you were applying this to a directory, if you did it without the recursive, then it would just do it to the directory, leave all the files alone. But if you want, all of the sub files, directories files, whatever is inside directory one to have the same ownership right here applied, you need to do -R. And of course, it's a -R because they didn't want to do the -R. Matter of fact, I couldn't find where there is a lowercase r there. It's just whoever wrote this, they preferred the capital R. All right, let's actually run through some of this real fast. I like examples. Control C, ls. So we have a directory right here. Let's go ahead and just cd into that. And I think there's a file. So file.txt. So if I did ls-l, and note, sometimes you'll catch me doing shortcuts like ll here. We'll talk about aliases. LL is actually alias to, it looks like a capital F and a -L here and a lowercase a in this case right here. So this is a shortcut. It should be on most of your systems there. But you'll see me doing both. Sometimes I shortcut it and sometimes I don't. So if we take a look, Jay Corcoran owns both of these files right here. So if we wanted to change that, I could do chown, and then we could just give root ownership right here. If I hit enter, let's see, change ownership of file operation not permitted. I'm a little surprised. Maybe it's because I'm giving root ownership of it. So we'll go ahead and back that up and add sudo and see if that's our issue. More than likely so. Yep, there it is. All right, so now we take a look at it and root is our ownership. And then if we wanted to change the group, chgrp, and then again, we'll just do root and file, and then probably need to do sudo again. And remember that little timeout right there. So it didn't make me put in my password this time. So now if we do ls-l, we can see we got both of those now being root and root. Now, if I wanted to change it back, we'll go ahead and do sudo, and then we'll do Jay Corcoran. Actually, I need a command in there, don't I? So we'll do chown this time, Jay Corcoran, and to show you that colon, and then Jay Corcoran, and then our actual argument of the file. Hit enter here, and then ls-l. Now you can see I've got it right back to where we started with Jay Corcoran there. Okay, when it comes to changing file permissions, there are two methods. There is the octal notation and symbolic. We'll cover symbolic first because it's a whole lot easier to understand at first glance. And then at first glance, you're like, well, why would I use anything else? Well, once we dive into the octal and you get octal, octal is actually way faster, more powerful, and I like it way better. To me, it's just simpler once you understand the concept. This one tends to the symbolic method. If you want to do anything that's beyond just like a single change, normally you're having to actually type out a whole lot more, and there's a whole lot more syntax that's involved. Okay, so symbolic method. So we got the chmod, its options, and then kind of everything that we can do with it. But let's break it down to something simpler. And that is right here, we've kind of got the classes. So U is going to be for the user, G is going to be for groups, O is for others, and then we can actually have A, and that's going to be user group and other, or you could simply specify UGO, and then it would apply everything to everyone there. Then we have our operator. So do we want to subtract some type of permission? We want to add, and then the equal sign. I don't like to think setting it to equal. I like thinking of overwrite because that is what it's going to do. It's actually very, very powerful. And some, if you aren't careful, you can actually apply the permissions that you really didn't mean to, because it is going to override, even in the sense that if you don't set a permission, so if you leave something off, then it's going to assume that you wanted to remove that. It's going to do just exactly what you typed. And then we have, of course, our permissions, read, write, and execute here. So let's look at an example. We don't need to worry about this part right here, but we have a current directory that we're using, and its current permissions are read, write, and execute on user, and then read only and read only for the group and other here. So we can kind of see that being displayed right here. So we talked about those groups. You can think of them as this right here, and I guess technically that so that would be D for the directory, and then we have user, and then we have group, and then other right here. It's kind of our blocked off permissions. Now, in this, if I say chmod and I say group, I want to add execute. So you can see, since I'm adding, it's going to, and that's group. So group already has read, write, and execute. So sorry, user has read, write, and execute. So group already has read, so it's going to preserve read, and it's just going to add an execute bit right there. And again, right here on other, it's going to add that execute bit. Of course, we give it the argument of where we want to apply that, and then we run the ls again, and now we can kind of see that perfectly matched right there. It just added that execute bit to both of those. All right, so here's some examples on this. So we do chmod group equals X. So what do y'all, well, I have it right here. So that's going to overwrite the that whole permission set. So we have read, write, and execute is possible. In this example, we don't know, but let's just assume that it had read and write on it. And if I did G equals X, then it's going to overwrite the read and write, and then it will only have execute permission. So we kind of lost our read and write right there. So in this case, if it had read and write and you want to preserve that, you wanted to use the equal sign, then you would say G equals RWX. Of course, the shortest way to do it would be G plus X. So it would preserve those. And of course, right here, we're just saying A. So that's going to be to everyone, user group other, and it's going to subtract the write permission. Here we're specifying other and group. So we're kind of combining just the two right there, and we're subtracting read, write, and execute. What will we be left with? Yeah, whatever the user had, right? Read, write, execute. We don't really know in this example. And then of course, chmod O. So we're doing others and group right here, and we're setting the equal to nothing. So therefore, we stripped all the permissions from group and other. And then this one, you can kind of see we're making different changes to everything. So we're setting user equal to RWX. Note that these have to touch. There is no space. It will error out if you put a space, and it has to have that comma, right? Why is my brain going blank? Not quote, comma, yeah, comma. G equals R, so group is set to read, and then of course stripping away all those permissions right there. All right, well, let's take a quick look on one of those right there. So we'll pull up our file here. We do chmod, and we can say, what do we got? All this. So let's just go ahead and do something simple. We'll set everything equal to RWX on file.txt. Now you can see full permissions right there. So what would I need to do if I wanted to, this is a file. So right now it's an executable file. I don't want that. So how could I just strip away all the execute permissions? Chmod. And you said, what did you say?
A minus X.
A minus X. Perfect. All right, so now we strip that all away. Okay, let's see. I want to, let's preserve the actual user permissions. Let's strip away the write permissions to group, and let's remove other, let's move all of theirs. Somebody work that out. What's the first thing I need to type here? chmod. Good. All right, now again, I want to preserve the existing permissions. What do I need to do here? What's my options? Let's do it that way. The what? The override? I could. What would be the laziest way of doing it? That's an option. We could go ahead, like if we want to preserve, we could say U equals RWX, so it would be the same. But what would be my laziest option? If I wanted to preserve it? Sorry, what? Leave it blank, do nothing. Perfect. Okay, now we said we want to remove write permissions from the group. So what's the easiest solution for that? G minus W. And again, I need a comma right there because we're doing something different with other here. And other, I just want to strip away all of their permission. So there's multiple ways of doing it. What you got? O minus RWX. Okay, so let's look at the current permissions right there. We could do it, it would allow it, but again, lazy as possible. So it doesn't have execute. So what could we do? Perfect. So if we did O and then minus RW, and then give ahead and give it our file name. All right, perfect. So not hard whatsoever. Again, the more you change that they're not similar, then the more you kind of have to type right there. So it's kind of give and take. Sometimes symbolic would be a lot quicker. Sometimes the octal mode is quicker. All right, so here is the octal method. So all you need to do is simply memorize this chart and figure out all the combinations of these right here and what their numbers equal on the side right there. No problem, right? All right. You could do that. I wouldn't suggest that. I think there is an easier method, and we'll just go over this. So possible permissions: read, write, and execute. So if we take a look right here, we'll just say, we'll take a look at this one right here, read first. So let's go over to our chart. And if we look at read turned on, so right here, yes, and then write is off, execute is off. So the only possibility is 4 right there. And then if we look at write right here, let's see, write by itself. Let's see, that would be here. So you can see write is here, X is off, mark them with X's here. And then lastly, execute bit right here, which is just the 1. So now if we look at that, this is off there. So those are the only 3 possible like combinations that are pure. So now if we take a look at this, we can say, okay, so we always know that read is going to be 4. We always know write is going to be 2. And we always know that X is going to be 1. So if I wanted this user, and we'll just say this applies nothing but to the user right here. So if I wanted to have read and write permissions, what would that be? 6. Perfect. Let's go and verify that. So if we clear this, we go to 6 here. Read is yes. Write is yes, executes no. Perfect. That makes it simple. All right. So if I wanting to have read and execute permissions, what would it be? 5. Let's verify. So if we go over here and look at 5, so we got on here, we got no here, we got yes. So perfect. We just simplified this to something just super easy. All we have to do is remember 4, 2, 1. 4 belongs to R, 2 belongs to W, 1 belongs to X, and every possible combination is just adding. So if it was read, write, and execute, then that equals 7. So now user would have read, write, and execute. All right, so how does this work right here? So we see now we have 7, 4, 4. So if we take a look at that, 7 is 4 plus 2 plus 1, 4, 2, 1, read, write, and execute. And we got 4, 4. Well, that is nothing but read right here. Boom, matches perfectly. So now if I want to change it and we're going to preserve read, write, and execute, here I want to add execute bits right here. So 4 is read, execute is 1. So I change it to 755. So if we look right here, that current permissions right there, I do chmod 755. Now we look at it and here's those execute permissions being applied. So we just have 3 different groups. Each group can have permissions from 0 to 7. That's all we have to remember. 4 plus 2 plus 1. We'll come back and we'll do some more of those here in a second. Real quick, UMask UMask is what determines when we create a file on our system, what is going to be the default permissions. And you can literally think of this as if this is the UMask on your system and here it's 2.2. So let's just spread it out here, 0, 2, 2. This right here is a special permission that we'll talk about later. So this is going to be our user, our group, and other. And you can think of these as being subtracted. So what was 2? Right permissions. So in this system right here, how it's set up, by default, it's going to be subtracting the right permissions off of every file that's created for other and group. The user right here, if I subtract 0, what permissions is it going to have? All of them. Read, write, and execute. Now, this can be changed right here on your system. You can apply it to Etsy profile. It's going to be changed globally for every user. That would be if you're a system administrator and you want to change it. Of course, we could add this to our bash RC file, and then only our local files are going to be changed right here. So we can see if I do UMask on my system, it has the same 0022. And then if we want to see, okay, what is the symbolic representation of that? Then it's the user having read, write, and execute permissions, the group having read and execute permissions, and other having read and execute. So if you see that, if you do it in the symbolic method right here, it's literally telling you exactly what those permissions would be. As you can see, the right permissions are missing on all of those. All right, so now that we kind of understand permissions and now we understand the role of UMask here, we're going to need to be able to calculate manually what would the actual files and directories on our system, what permissions would they have by default. So it allows us to figure out what the system would do. And I mean, again, not so useful in real life, but it is, this helps you understand what's going on in the background, and it will be on your test right here. With the UMask, we can get that from our system. Note this one's different. It has 3 zeros from the front, and there's only one change. It's the other on there. Of course, we can see it symbolically. Now, we have this, the magic numbers. Now I'm going to tell you there's nowhere on your system that these numbers exist right here. This is just for us to help understand what's going on. So if we start with this magic number and we just write it down, and then we get our UMask and we take and we subtract our UMask, you can see the resulting number here is 0775, which makes perfect sense right here because 7 just comes down, 7 comes down there, and then we subtract 2 from 7, we get 5 right there. Of course, we know that 7 is read, write, and execute, read, write, and execute. 5 is 4 and 1, so it's read and it's execute permissions. This person has no write permissions on the directory right here. Now, pay special attention to the fact that we're in directory because that will affect something here in a minute. Now, to understand what's going on, we could stop here and there's another way to calculate this, but that is if we have the permissions for directory and we want to understand what permissions for the file would be, then we can simply subtract 0111. So what am I subtracting if I subtracted 0111? Say that again.
The ability to execute on all.
Perfect. So that is removing the execute bits from all files. Why do you think we want to do that? Because understand, I should have said this. This happens by default for all files. You might think why the files wouldn't have execute permissions by default.
Every file you're gonna make is gonna be an execute.
Perfect. You don't want to, if I create a text document, I don't want it to be an executable program. It's kind of a bad thing to have everything executable on my system. I could actually mess something up there. So by default, no matter what the UMask is right here,
it is understood that if it is a file, it is going to subtract 0111 from it. So we have two different methods. We could actually just go ahead and do the directory, and then whatever permission is on the directory, we could subtract 0111 from that and get the actual files right here. Or we could change the magic number to go ahead and be 0666, which already has 111 removed. So all the execute bits are removed from that magic number. So if we wanted to do that, you'll see we get the same set of permissions. So if I just substitute that for 0666, go ahead and subtract our UMass, we get the same answer as we do on the previous slide there. So this right here is a big part when it comes on the exam. What gets forgotten, and that is if the words directory, and understand this, it's just one word in a sentence, but it's very, very powerful right here. If I say directory, your magic number is 0777. If I say it is a file, then your magic number has to be 0666. If you don't, you get the wrong answers. These are very, very simple. Yet every single time, several people mess these up on the exam. The second thing that they get mixed up with is symbolic and octal. So again, symbolic is, when you actually type out RWX, octal is when you use the number set. So don't get those confused. What you got?
So the magic number, are those just basically hard coded into Linux?
Yeah, I mean, they exist, yes, but you won't find them anywhere on there. That's just because of the highest number, RWX 421 is 7.
So you would never want to mess with those. You would just mess with your UMass if you wanted to change.
Yeah, I don't even know how you would change those numbers. I don't know where to even find them on the system. They probably are on there somewhere, but it's not easily to find those numbers. I wouldn't know where to start on it. Okay, so let's kind of do this here. So let's say we got read, write, and execute, and this is going to be we'll say it's a file right here, and we'll do RW, and we'll leave that blank right here. Okay, so if I was going to write a chmod command using octal notation, what would my command be? And notice in this case, I'm asking for 4 here. So remember that 0. So we'll just go ahead and start with that. It should be 0, which is a special permission we'll come to. All right, so somebody tell me. Let's just break it down so you understand. User, group, other. So what's my octal notation?
That'd be 760.
760. So we do 7, and then of course 4 and 2. So that's how we're getting that 6, and then 0 right here. Perfect. So if we got RW, and then we'll say RX, and then we'll say X right here. All right. Somebody give me that one. You said 6. What next? 5 and 1. Sure enough, because that's 4 and 2, that's 4 and 1, and that's 1. So 0, 6, 5, 1. All right, pretty simple, right? Once you understand this octal, you can just knock it out really quick, and I prefer it over the actual symbolic method, except for like 2 scenarios that we'll talk a little bit later. All right, does anybody need some more examples here on this? Any questions on it? Okay, perfect. All right, because we're gonna make it a little harder here. Let's move this, and let's just say our UMass, we're going to give 0, 2, 2, and we'll do a directory first right here. So somebody tell me, what's my magic number? 0, 7, 7, 7. All right. So what I need to do with the UMass, what importance does it play? Subtract it. So I'm just going to bring it down here. All right. Somebody do the math on it. What do we have? 0, 7, 5, 5. Okay. What is the symbolic representation of that? Okay. And I just do it. Oh, cool. Read, execute, and then read, execute. All right. So we just did it the opposite way here. Kind of. So when it comes to doing this symbolic method, it's almost is better as far as math wise on your exam. You kind of still need to do this part right here in your head to figure it out. So understanding the octal is way more important than the symbolic right there, especially when it comes to your exam. All right. Are we good? Any more examples on that? Once you understand the process, I mean, it's just simple subtracting. I mean, your number gets no higher than 7, but still a lot of people will get this wrong on their exam. So don't overlook it. I think sometimes it gets to be so simple in the class, and then you get to the exam and you realize you forgot a few things there. All right, so that is the basics when it comes to the permissions. Now, here is where we muddy the water up a lot by introducing kind of something that was added on, and there is no good place for it. So that's where it gets interesting. All right, I hate this actual term right here, but make sure you memorize it, because when I put it on the exam, I don't know a better way to do it than the actual true term of it. So this is set user ID. It is a special permission, and it allows you, so it's a permission. So when the process executing a file takes on the privileges of the file's owner. So what that means is a good example of this, and we'll look it up in a second, is the password command. So the password command, we don't own that command whatsoever. We don't own hardly, we don't own really any of the commands on Linux. Root owns those commands. So if we need to be able to use those commands, then we, the system will put set UID on the password command, and it allows you to run that command without any type of sudo privileges. So a normal user could run this command, and then he will take on the privileges of the file's owner, which in that case, root is the owner. So you temporarily get the privileges of root for that one specific command, and only in the scope of a file that you own. So it doesn't give you permission to go and change somebody else's password or edit their file. It's just something that you own. You temporarily get root privileges with that command, just for, kind of that instance itself. So this is the workaround for you to be able to change your password on your system. So let's take a look at that. So if we did which, and then password, which is PASSWD, not fully spelled out there. So that kind of gives us the actual location of that. So now if we did ls-l, paste in that, and we can see right here that it has a weird permission right here, right? What looks weird? The S right there. So the S is the set user ID. And we'll talk about it more. We'll just let you know the S is there, and we'll talk about it in a second to kind of explain how we read it a little bit better. Then we also have the set group ID, and this is one of those things I'm just going to tell you because it's there, but they've changed it, and it's one of those. If I apply it to the password, and root is the group owner of that password, yes, it will do the exact same thing, but it is against best practices to do so. So I would say just kind of ignore this. What it is good for, we'll fast forward to this, is on directories. This is something that they added for it to give it a little bit more meaning. So if you apply set group ID to a directory, then what that means is, so at the end of the semester, we're going to be on a Linux server. We're all going to be a part of a group called Linux-class or something like that. And so that'll be applied to a directory. So everybody can get in that directory. You can all create a file. So by default, when you create a file, you would be the owner of it, and you would be the group owner of it. But if I apply set group ID to a directory, then when you create a file, you will be the owner, and then it will take on the group ownership of its parent. So it would then apply Linux-class to the group. So therefore, we can all access each other's files. So that's kind of the weird thing that it does. And again, just kind of don't use it on files, only use it on directories. And then if you want that, set UID, then of course it needs to be applied to the user, and then don't use the group. Let's see. Of course, this is a security issue. You don't want to apply it to scripts. You need to use it very sparingly. I've actually never encountered, of course, it's mainly when you want to write a command that other people can use. That's really its only use case scenario there. Let's see here. So now to kind of see all of them at a glance, we have set UID, set group ID. We haven't talked about the sticky bit because it's kind of different right there. And then notice the values. Same values as read, write, and execute, 4, 2, and 1 right here. So same rules apply. If I added 4 and 2, got 6, then we would be applying set UID and set group ID. Of course, that's kind of a bad combination because I told you you shouldn't do that. And, set UID should be to a file, set group ID should be a directory, but it's still possible. You can do it. It would just be against the, best practice there. And then we have a sticky bit, which we'll talk about in a second, and it's kind of replacing that execute bit there. All right, so here is an example, again, a bad example because I'm applying it to an actual file here. As you can see, we've kind of create a file called test. We're adding execute bits to the group, the user, and other. Very, very long way of doing it, not a very efficient way. And then now we can see here's the permissions, and then I'm doing chmod. So for the user, I'm adding set UID. For the group, I added set group ID. So now we see the permissions changed right here to RWS. So what's the question you're asking yourself right now when you see those permissions? Anything jump out at you? What you got? That is true. So that's good. So you can see plus S, you're like, well, how does that distinguish between one set UID, one set group? It is just like it's because I applied it to the U right here, it's going to be set UID. If I apply it to a group, it's going to default to the set group ID just because of where I placed it right there. I could combine this to UG and do plus S, and it would know what to do. It would apply set UID where it goes and set group ID where it goes. What about the S right here? I mean, that's kind of strange, isn't it? How do I know if there's execute permissions or not execute permissions now? All right, let's do a little test. Okay, so let's see what file. We got test file here. Again, now let's just go ahead and give full permissions right here. So somebody, I want read, write, and execute on all of them. Somebody tell me what's a good short way to do that. Perfect. Okay, so now we got those full permissions. Now I'm going to say chmod. I'm going to say we'll actually do it with the symbolic method first, since that's our example. We'll say user and group here, and then we'll do plus S on file.txt. Now let's run it again. All right, so now we can see S happen. Now, did I have execute permissions on it before? Yes. So here's the catch. If it is a little s, it is understood the execute permissions are there behind it. Remember, this is an add-on. They had to figure out something. So how do we actually know if it doesn't have it? Well, let's find out. Let's do chmod, and we'll say UG minus X on file.txt. So I'm removing the execute bits on user and group there. Hit enter, LL. Now what's different? There's a big S. That looks different. That looks odd. That's how you know. It's that simple. What you got?
So you can't check if it's there without removing it, like that's the only way.
No. You know it, and it is so silly. If it is a lowercase, then it's there. If it is a capital, then that looks different. There's no other capital permissions that we have. They just needed a way to distinguish it. So they chose a capital letter. So now we know that the execute bits are not there, and we can kind of prove that if we went and did chmod UG minus the S's on file.txt. Now you can see, of course, we did it up there, we know it, but we can prove it but that way. So now there was no execute permission. So if it's capital, there's nothing behind it. If it's lowercase, then there's something behind it. Now, luckily, it's only on the execute bits. Even when we come to the sticky bit, It will only be that execute bit. Okay, when it comes to setting them with Octal, we just use that 0, kind of the prefix to it right here. So in this case, chmod, if we do 4 is set UID. So we've applied set UID to it. 2 is going to be the set group ID. And then of course, combining it 6+, then you can see you get both of the S's, kind of what we did with that symbolic there. All right, let's see, sticky bit here. Okay. So originally the sticky bit was if there was limited resources, especially when it came to RAM, you didn't have much RAM. If your system's RAM was filling up, then it could simply move some of that data over to what they call the swap drive. It was a little partition on the drive that would basically use for RAM, and it would just hold something there. Of course, it's going to be slow on the transfer because it still has to spin that disk back in the day. Now, we don't have these problems anymore. We have lots of RAM to play with, so the whole swap file is kind of a thing of the past. So they changed it. It's now called the restricted deletion flag. And if it's applied to a directory, in our scenario where we're all in the same group on the Linux class server, and one of you create a file on there, if the directory has the restricted deletion flag, then that means that only the owner of that file or someone with super user privileges can delete the file. Now, at first glance, that sounds great. That's really, really cool. Very useful. But the downside to it is if one of you wind up getting on there, creating a file, and of course, that file is owned by you, it has group ownership of Linux-class or group there. And then you could then, if you had write permissions to the file, you could simply get in there, delete all the contents of the file and save it. Then all the contents are gone. You couldn't delete the file, but you could delete all its contents. So, you know, how useful is it? I don't really know. It kind of depends on how you have your drive set up. If you don't give write permissions to the group where they can only read the contents of the file and then can't delete it, then everything is protected right there. It really depends on what you need in that scenario, whether it's effective or not. Okay, real quick, we'll do an expanded example right here. We'll have a directory. This directory, hang on. I need my divider, so I thought that would pop up automatically. Okay, let's see here. We'll do a directory with read, write, execute, of course. We will say that you can read and you can execute here. And these people can only, we'll just say they have nothing right here. All right. So if I was to come over here and do chmod, and let's do, since this is a directory, we will do 3, and then we'll say 7, and then let's go ahead and give 150. Okay, so somebody tell me what would be, and I don't have it perfectly set up because some of these might technically need more blocks, but we'll just work through it anyway. So somebody tell me, what did I do? What is the symbolic representation of what I just did? A change on it. I'll tell you what, I'll even put the key up here. What did I do? Group ID. Okay, so let's break it down. What did I do to the user here? Anything? Did I do anything to the user? Nothing. So the user has read, write, and execute permissions here. All right, now, what'd you say I did to group? Okay. So somebody tell me, we'll fully write it out here. I know I've only got 3 categories. Somebody just tell me, what permissions does group have on it? Okay, so actually I have enough, right? Okay, yeah, perfect. So S and then set group ID. That's perfect. So note that when you actually set this, if you set it out using symbolic method, you would actually say RWXS. It would be 4 characters, even though when the machine interprets it and it's being displayed, it would do that lowercase s, and I did that wrong, didn't I? So it would be that right there. RWS. So the X would be understood because it is a lowercase s right there. All right. And then what's my permission here? It's nothing, right? All right. Good deal. Now, is that clear as mud? Do we need any more examples on that? What you got?
If you're trying to remove the set UID. And you're trying to do it symbolically. Can you just do -s, or does that remove the execute permissions as well?
So are you saying don't specify a group, just -s?
No, you can specify, a group,
Okay,
but if you -s, does that get rid of the execute as well?
no, it will not.
Can you
Yeah.
minus?
I've never tried that. I mean, there's no need to do it because the S would get it, whether if it has execute or not, it would be the same thing right there. Something that you pointed out that is really good. Well, let's look at it here. Shorthand stuff. All right, so let's do ls-l again. Now let's go ahead, do chmod, and let's just go ahead and yeah, we'll do it that way. So chmod, and if I just say +s to file.txt, hit enter, look what happened. So it applied it because it defaulted to that. Now here's the interesting, and have we hit the sticky bit? We did. We covered everything on the sticky bit, right? Yeah. Okay. So if I did bring up my previous command here and delete that and hit a T +T, and then we do LL again. I'll look right here. So I don't think I showed you this, and I should have. The sticky bit is a T. And because it is the only T, if I just did +T, then it knows that the only one I can apply it to is other. And of course, we know that this has execute. If it didn't, it would have a capital T there. But if we do just a +S, which again, you should never do that because you should only apply the set UID to a group and the set user ID to a user. But as you saw, we did it right here. It lets us do it. The +S would then apply to the single one. Now, if I wanted again to just remove from say the group right here, since it's a file, I could say G -S, and then you can see now it wind up removing that the set group ID from it right there. All right. Any other questions? Those are great questions. What you got? Minimize this.
So 3, I think that's the idea.
Yes, right here, those two, because 2 and 1. So that means you get the set group ID in sticky. And I see your point. I just moved on and didn't even apply to that. So in this one, what should it be? Sorry, what was that? T. Yeah. So, and uppercase, lowercase t. Good catch. That's awesome.
So, have 3, 7, 5. 5 is 3.
Yes.
So as far as, bottom. Bottom or.
You talking this right here?
Yeah. That's something. So,
Yeah, the S right here is coming because this would be 2 right here from that. So we get the set group ID. And since it had an X, now I know it's not perfect right here, but that's a lowercase s, not a capital.
Yeah.
A little bit bigger. Yeah.
Yeah. So, yeah.
Great questions. Anybody else? What you got?
So we're adding the sticky bit, so it defaults to being lowercase, which means there's also an X permission. Or it defaults uppercase.
Yeah. Gosh. I sat there and said that to you, and I'm confusing y'all because there is no execute bit here. So if it's missing, then it is a capital T. I'm sorry, I'm not on my A game.
Right here. So does that answer your question? Or were you just confused because I screwed it up?
Yeah, that's it.
Y'all gotta catch on with stuff.
So is it like a common thing that the lowercase letters are being executed, the uppercase letters being not executed, or is that like a bad thing?
From what I read, and you have to understand Linux is, again, all the permissions by default are lowercase.
Okay.
So that looks normal. If something is uppercase, that doesn't look normal. So that's how they distinguished it from it. It was, they had no good option is what, without having to rewrite so much. So this is what they can do. But yes, it is weird. It's difficult at first to remember all these little nuances. Okay, so lastly here, we have access control lists. Luckily, as far as this class and you go, this isn't something you have to know, as it is outside the scope of our class right here. They provide a finer grain of control. So it's kind of really beefed up access or the ability to control users' access on the system. But the problem is they're not built in. It is kind of a package that comes after that you have to download and install and then manage. So with that, they have some negatives, and that is they impact performance. So they're going to slow your system down. So you can never use them on system files because you don't want to impact the performance of the system there. And then the big one, which is one of the main reasons why we don't cover them, is they, a lot of utilities don't honor them. So you really kind of have to dig in and figure out if it's going to work on your system or not. And then if you try to move files from one system that has it into another system that doesn't have it, then you're going to have trouble. It's probably not going to work when you want one. If you don't have it installed, it's definitely not going to work. So it's hard to share your files under a system that has ACLs because not everyone's going to have those on their system. So. All right, real quick, discard all of that. Let's take a look here. So module 2, I need to open this up. So you've got a lab. I'm going to make that available, and I will edit the due dates on these right after class. Well, I guess I can, let's see when they are, so I don't forget. So let's see, what is today? Oh, today is not December here. So again, I'm doing years. That's not good, is it? Let's see, 2025. Move to January.
It's 2026.
Man, 2026. It's, yeah, so y'all need me to do this in front of you. All right, so today's the 28th, so the 29th, and then we'll make that due by the end of day right there. So simple lab for y'all to go through, and it will be due tomorrow night by 11:59 p.m. And then this assign one, let's change its due date. So this assign one, it is simply it's kind of like a quiz or a test, but it's all open book. There, y'all can take that home. It's going over some of the terms that we've done. The big part of what this is going to do, it's going to prove to me whether if you got the permissions or not, because there's going to be, that's kind of the bulk of it. Y'all are going to be doing the permissions on there. Matter of fact, I'd like to get in there and show y'all one thing real fast before y'all move on. So let's see, it's the 28th, man, it's because I do the 25th and then I roll it over. That's my bad. Okay, so Friday, let's make this due. We'll say we'll make it due Sunday by 11:59 p.m. That'll be plenty of time, open book. Now, let me make sure this isn't going to give some answers away because I can't remember if it does. Edit the test options. I tell you what, I can just open it up right here. Hit begin. Okay, yeah, perfect right here. So make sure y'all pay attention on this. So I'm telling you for grading purposes, you can see right here, I've got the example of 0, 0, 0 minus. So all you're doing right there is it's a directory. So you need to know your magic number. I'm giving you UMass, you would plug that in, and then you tell me what it equals at the end, that symbol, but in 4 characters.
right there. I don't want it just being like, if it was octal, 777, I'd want it to be 0777. That is because on some of these, I may be throwing in some of those special permissions, so it's nice that we keep that 4 digits right there. And then note right here, on these, I went ahead and specified user right here, so that you would just give me the permission. Don't actually do U equals, just I'm giving you the user, I'm giving you the group. So I'm kind of limiting to you, so I don't have to sit there and
Code and write, all the different ways you could do it. I'm kind of limiting you. And then I will, I think, later open up to some more free stuff. Just make sure you pay attention to that. I'm kind of giving you a cue already right there. That this is symbolic because I'm breaking it up into those groups right there. All right. Any questions? All right, y'all are good. I will see you Thursday.